Hello, good morning everybody, and welcome to this webinar from Grundfos regarding the adoption of private pumping stations. Thanks very much for coming along today to listen into this, and we know the adoption of the pumping stations is raising a lot of interest, and I think that's reflected in the numbers that we've got on the call today. In terms of a bit of housekeeping, we welcome any questions that you ask. There's a question pod on your screen. So please feel free to answer those and ask those questions, and we'll look to answer them if we can today. If not, we'll come back to you separately. The presentation will also be available online after this webinar if you want to run through some other things. What we wanted to do today is to bring together some of the issues raised and discussed with some of our stakeholders recently and last year around the adoption of the pumping stations, and from the experience that Matt and I have got from looking at these stations and talking with the customers and talking with the wider Grundfos team that have been engaging with the water companies. Take some of the insight that we've got from that into the presentation. So we know that the water companies are going to be adopting the private pumping stations in October 2016, and we know that this is an issue for the industry in the whole. And when I say we today during this presentation, I'm looking at that as us as an industry and together to overcome some of the issues out there. There are certain aspects, I think, of the adoption of the pumping stations that are still unclear, and some of the things like the number of stations and where the stations are and how much money we're going to have from the regulator to look after them. So there are a number of issues there, and we know that the water companies are wrestling with some of these issues as we speak, and we're working with them to help them with that. However, there are a number of things that we do know, and we've tried to use the analogy of a jigsaw to look at some of these things that we need to consider, and we'll look at a number of these in a bit more depth as part of this presentation and how Grundfos have looked at some of these things, and we've addressed it with some products and services that we have. Firstly, and I think the most important thing that we've got to consider is the customer. It's a key element to this, and we're going to be entering a relatively new environment here as stakeholders working in domestic environments, and I know that we have adopted the private years ago. However, a lot of that is not inside the building, and we can carry out a lot of the work outside of the building. Here, from what we've seen, we've got lots of assets that are inside buildings, in garages, and we need to look at that, and we need to look at our different mindset working in that environment. And Grundfos has got quite a lot of experience of that with our heritage in building services. We need to look at how we work with the customers in terms of call center services. We're going to see an increase in calls. We're going to have a lot of new data that we've got to deal with. How should we address that? We've got to look at the scheduling of work to these domestic properties, access to the domestic properties and to the facilities where some of these assets sit, and what that might mean in scheduling and abortive calls. We need to look at how these stations will be metered and how customers might be billed for electricity that they are using, and if that's off the customer's current electricity supply. Over and all, we've got to look at the disruption that this is going to cause and what that might mean also to some of the regulatory measurements that Ofwat might put in around this and things such as what we do know is that the water companies are going to receive a whole raft of different assets, different shapes and sizes of assets. And we need to look at how we're going to make sense of that and how we're going to create an asset strategy and an investment program to address the improvement to those assets where that's needed, and the capital costs that we have, and importantly the TOTEX around that. We need to look at the priorities. Safety, first of all, most important. We do believe, and from what we've seen, some of these assets aren't safe, either in terms of access or in terms of their current integrity. We need to look at the environmental impact, and of course we need to look at the customer impact. We need to look at the maintenance strategies that we might look at with regard to some of these assets. And we're going to see a lot of new data. We're going to inherit a whole new set of assets. What are we going to do with that data? How are we going to collect it and manage it? And how are we importantly going to use that data going forward to improve things and make good decisions? As I say, we're going to be faced with all sorts of assets and all sorts of shapes and sizes, and we're going to have operators and maintenance guys who are going to be going to site and dealing with sites that are essentially potentially not as safe as we're used to. We've got to very quickly understand that and address the health and safety issues for our look at the resources. We've got that inevitably will resources to carry out activities. Where's that going to come from? And how do we minimize loss? We're going to have call-outs. How again do we minimize call-outs? And when we do go out, how do we make sure that any rectification is done right first time in order to minimize impact in terms of cost and operational resource? And one of the things that we're hearing quite a lot is the concern is around security. Some of these assets are in customers' properties. What's going to stop them from tampering with some of these assets and impacting on the costs? Of course, are always important to us, particularly around maintenance costs and particularly around call-outs. And the graphic on the right-hand side shows a typical whole life cost of a pump and pumping station, where 5% is the initial maintenance and the energy typically 85%. What we're going to see here is lots of much smaller pumping stations, typically smaller than 2 kilowatts, and what we believe will actually happen is that those costs are likely to flip over, and that the maintenance costs through blockaging and overall maintenance will be significantly higher than power. If we take an example of some of the stations that we've looked at so far, some of these stations are using less than 100 kilowatts per annum, and if we put that into pound note terms, that's something like £15 per year. If you compare that to one site visit to unblock a pump at, say, £200, you can see that the really important thing is to get the blocking and characteristics right so that we don't have those call-outs. Accepting, however, that there are some pumping stations that are bigger and power efficiency becomes more of a factor. We're going to have to do some project work. We're going to have to improve these assets, and safety is again key to that. In a domestic environment where we've got less space, we are going to be very close to working in with our customers, and we don't have the same abilities perhaps to fence off areas. We've got to look at how we ensure we do that, and how that creates a solution that is safe during the construction, but also subsequently for the operation and maintenance activities. Projects will cause disruption. We can see some images there of really well manicured landscapes, and then what we might have to do and what we've seen to overcome some of the project work. One of the things that some of the people we've been talking to in the water companies are talking about is separate power supplies. So that in itself will cause significant disruption in bringing the supplies in, and the logistics of that in terms of working with the DNOs in getting separate power connections. So we've got to look at all of that, the space and the access. So a number of really key issues in there. So what can Grundfos do to bring those pieces of the jigsaw together? We've got lots of products and activities that we've been looking at with our customers, and I'm now going to hand over to Matt, who's going to talk you through some of the things that we've been doing.
Up with an auto-adapt pump, he could remove one of the healthy pumps, put in an auto-adapt into a safe electrical supply, and then that station would be fully operational, getting the customer out of trouble and obviously taking that heat off the situation. To then make the decision then can be looked to see what is the next step, whether it's another auto-adapt pump in its place or a replacement control panel in the future. It also allows us to look at the historical information that is being collected via the pumps, so we can then look at maintenance strategies sat behind individual stations. So if there's high maintenance stations or problematic stations, we can make sure we hit it with the right approach. Again, the customer faces less disruption, and with it being a plug and pump, that call out, as mentioned previously, project. This can obviously help in the project, from the initial off. We're saving in access and location and space availability with the size of the CIU, the common control panel, and it's not even needed. You don't need to have that space for a control panel. And lastly, it reduces the capital cost. You haven't got a control panel that you've got to fit. You haven't got float switches that have got to be set up or fitted or bought, and you haven't got that labour, that site labour to install those components. It is two pumps connected to two local isolators and a healthy supply, so that capital cost can be greatly reduced. So another solution that we have to assist in this jigsaw puzzle is the package pump stations that we've developed. We've got GRP stations as well as polyethylene. Are all that can be modular in design. We can cover a vast range of sizes, through big to small to narrow to cope with many different installations and things that we may be faced with. Some of the features of the push station: we've got the heavy traffic, we've got the PE covers, and we've also got quite another innovation in the tank is the bench tank from that allows the sludge to basically be sort of guided towards the pump, so we can reduce the tankering by getting rid of that sludge and assisting that pump in getting rid of that debris. You can see some of the extras and some of the different variants in this slide here. For myself is the stainless steel option of the pipework integral to the pump stations. With a lot of these domestic stations, you'll find that they are very small, and if you ever have to replace footstools within these stations, it's not every engineer that can get in there to do that under confined spaces. And obviously it's a high risk health and safety activity, so if we can minimize that and reduce that risk with having stainless steel in there to prolong that life of the station, I think is very, very important. But we have other options of the galvanized pipework or the PVC ABS pipework that you're probably familiar with. Another key safety feature familiar to most utilities companies now is a key feature. I think we don't need to cut corners, even though it's we're looking in reduced station size. We also have the option for separate valve chambers. which I think covers the whiz and WIME specs presently, so we can adapt quite happily what we need to do in these projects. As you can see from that picture on the bottom, with a large pumping station, we can deal with that as well. So covering the jigsaw pieces, obviously health and safety there is a big one, as I spoke about, with the reduced risk with the features, safety grills, lockable covers. We've got reduced site labour with off-site build. We can get it all correct in the factory and test it in the factory prior to being delivered to site. So we're again looking at reducing the capital engineering time and other sort of solutions with the concrete pours. It's being done in a factory environment and reducing those costs. Project delivery, again, lessening that disruption, less time on site, less footprint, less damage to the property, less sort of footprint that we need to take up. And with the full range that we have with all the different sizes, we can look at reducing the space availability that we've got, covering that. And we can look with lower maintenance with the benching and the stainless steel and other, the maintenance to lower those tanks with the benching that historically can cause the stations themselves. That I'd like to bring to the remote monitoring as GRM. The concept of this, we are able to have the slides haven't been pulled through. The network CIU modules talking into it. This is then hosted in our center, be accessed either via a secure internet connection, and you can see the overview of the pump stations in the screenshots on the right hand side. The GRM features and benefits we can give out from the pump stations that have got the auto adapt feature, high level and overflows, motor heating, and time for service. This system also works and can be used in conjunction with other manufacturers' pumps. It's not just suited to the auto adapt, so it's flexible in that sense. A lot of you will already know the benefits of monitoring stations. It's heavily done already in the utilities market, so I'm not really going to sort of explain why there's benefits of these, but what we can say is we can offer these benefits in the world of the private pumping station adoption, and we can look at all the different aspects of what's going on with that station, so we can look at performance and how we could possibly increase or find out trends that may be there. And again, because it's real-time data, you can check as listed in the slide all those parameters, which I'll talk about on the next set of slides. We currently have a trial going on at the moment, which is using the auto adapt concept and GRM, and one of our macerators. The particular station in question is a pumping station that shares or has been with 3 homes. It's been a problematic site with heavy reg content and suffered frequent blockages. So we've installed 2 pumps, some new change, non-return valves, and our CIU 272 with. And you can see from the install, you've got the original control panel there in the top left-hand corner. and on the right you can see the float switches located within the sump. And a single breaker box with the CIU unit fitted there as well, and that obviously then eliminates the float switches, and you can see in the bottom right hand picture there that we've got the 2 pumps. So that is the change that's taken place, and as you can see there's nothing there that can really be pushed in contrast to the control panel in the top picture. And keep an eye on what's going on with our GRM. You can see that from the screenshot that we've named this as a water utility site. This would be the area or that's mainly in question, and you can also see here that the location of that particular sump and address. So you can have infinite number of pumping stations on this. So if you had 300, 500 pumping stations, or 12, or it can all be seen from high level. Then we can interrogate this particular pump station, and we can have a look and see that everything's okay, and have a look in the station itself and what's going on. But unfortunately, sometimes it's not okay, and you're probably wondering where I'm going with this one. With this trial that we've had going on, the pumps were fitted, and it was about 4 weeks in, and I received a text message and an email on my phone basically telling me that there was a power out at the pump station. So I thought I'd give a courteous phone call to the homeowner and just say that I think there's possibly a problem. The pumps have lost power. So I gave him a call, to which he answered the phone, sort of quite shocked, as I sort of mentioned, I think there's a problem with the pumps, you've got no power. To which he replied, well, no, my pumps are fine, but my toaster's just gone bang. And with that, he found it amazing that I was actually able to sort of know this information as he was en route to the fuse box to reset the breakers to try and finish his cooking his lunch. But what he commented was that this was quite a unique feature, really, because the previous summer one of the pumps had actually tripped the main electric, and he had lost the contents of his freezer whilst he was on holiday because there was no electric in the house. So it sort of it opened us up to the new environment in which we'll be operating, and new sort of issues that we may be faced with, however unexpected they may be. So returning back to the GRM and what we can look at and what we can see there an indication of the level of the sump. Again, that is real-time data, and that can be extremely useful. And we can also see the overview of the 2 pumps, what's fitted, serial numbers, and their current status, and you can see in there some of the operating hours and temperatures and ampage that it's been using, and more importantly energy consumption, which I'll come on to in shortly. Here we have the trends that we can look at. Here we have the number of starts, which there you can see pump 1 being blue and pump 2 being green. Shows the alternation of the pumps. They're both operating together, and the days that they've obviously been used quite a lot, which can indicate any ingress of water to the station via the drainage network or rain into the sumps, which from this station in this live trial we've actually proved now that there are rainwater is getting into this sump. We can see the pit water level and see that the pattern of usage again, which is real-time data and how many starts. We can also see the current that's being used. Now this is quite a nice feature to have, being able to monitor this current, especially with a grinder pump, because we can see if the grinder pump's starting to get into trouble, possibly whether the blades are starting to get worn. Or if the pump itself is starting to jam up and obviously causing a lot higher ampage. So you can actually use this as a bit of a detection pre-failure, so you can get in there pre-call out and get something done about it. And again, you can see this is just showing the water level again, but it's max and minimum, and any dual use that may be coming in. This leads us on to the settings. These are all changeable remotely. You don't need to put an engineer to site to change these, and these can be such as the high level, start levels, and the start band. And also you can change some of the key features. Again, I mentioned previously we've got the anti-seize function, or anti-block as it's listed here. So on the macerated pumps, we know inherently they are notorious if they've not been used for some time to seize up. So you can actually have that to run for 2 seconds every 3 days, or when you choose. We've also got the after run there that allows for the snore feature, or foam drain, to clear the excess debris that may be accumulated in the sump itself. So the final slide that we can see is we can put in the customer information, customer contacts and details. We've got a picture that we can have, and have as many pictures in there as we so wish. So anyone going to that site, or pre-going to that site, or anyone talking about this site over the phone to help with the triage of the problems, it's got the information. And you can also see that you've got the documentation of the pumps that are fitted, and any installation manuals or flow characteristics, flow curves, can be all documented within here and stored in the one place. So over the next 2 slides, I'll go over the pieces of the puzzle that we can quite safely say we've covered off. Again, mainly the customer through the call centers, and how we can interact with those call centers, whether it's from our GRM or whether it's our system talking to someone else's system, such as SAP maintenance. It's storing that data that could be shared. It assists with the scheduling of preemptive maintenance, or maintenance visits, actually service a pump due to its operating hours as opposed to time. So if it has done its 3,000 hours, you can actually monitor that effectively. And again, looking at reducing those aborted calls. Asset management, it pretty much covers all that that we've spoke about and what Andrew mentioned. With the plan versus reactive maintenance strategies, we can see that the stations that are out there that are high maintenance and suffering maybe with some neglect, or some education that may be needed for the customers that are using it. Asset data collection, again, it's storing all this information that can be used to get things right first time, and making those decisions far better. Call out, it's sending that information to that call center, or to that individual service team, letting them know of the problem. It gives them a true indication of what that fault is. It's not just a high level, it's telling them what's happened. They can interrogate it before they get there to get that right time fix, right first time fix. It also covers electricity metering. Now we know that it's not going to be a calibrated device for billing, but what it can do, it records that kilowatts used, so it can be used as a judgment, and a sort of a first glance to see how busy this station is. So it's a nice to have feature for a very small station, which is done effectively. And again, we've covered with the scheduling, the planned reactive works, and how we can get in there and get that covered, and make sure that it's effective scheduling to put those maintenance strategies together. And overall, lowering those operating costs by using the trends and looking at the data that we have, we can make sure that we're making the right decisions to increase that performance, and optimize those stations to operate where they should be. Again, keeping those costs down, which is most important. So I'll pass you back to Andrew now, and thank you for listening, and many thanks.
Thank you, Matt. And I think in summary here, we're just Thank you, Matt. And I think in summary here, we just want to go through some of the things that we've talked about that bring together the pieces of the jigsaw. I think first and the customer experience is central to making this work. Make sure that we create solutions that minimize our time on site and the disruption to the customer, and to minimize the space that some of these new that we want to put in use. And you've seen from some of the slides today how we can do that. One of the key things we've got to look at is being flexible and versatile in what we do. We know that different water companies are taking different approaches to way they are looking over these pumping stations. Control side of things, what we need to be able to do is to provide solutions that are versatile to meet those individual water company needs. And safety, it's really important that we don't compromise our safety because of these new pumping systems. We've got to make sure that we provide the solutions that do that. And again, some of the things that we've done today and have got available to us allow us to do that quickly in the first few months, if even, and years of running these assets. The remote monitoring is really key there to starting to improve the way in which we work with the customer and the amount and making good decisions. It is because we had the information and we took the right parts with us, because we knew what assets were and what the problem was from some remote monitoring and some interrogation of that remote monitoring, so we could make the right decision forward. But we've got to collect as well. These, as I say, are lots of new assets, and we need to bring that data, do some proper asset management and through the project work that we carry out. So I think you've seen there a number of things that we've been doing with some of the water companies, with the auto adapt and with the controls, and that will enable us to address a number of these issues and bring the pieces of the jigsaw together as we go forward as an industry. So I'd like to thank you all for listening in today to the presentation. As we said, the presentation will be available online for you later, but what we'll do now is that we'll spend some time going through some of the questions that have been raised on the presentation. So there's a question here around do the auto adapt pumps need to be fitted on guide rails? Matt, do you answer that one?
Yes, the auto adapt pumps, they can be fitted on guide rails, or they can be self-standing and fitted to a flexible hose. There isn't the need for the actual the guide rail system. They're fully flexible. So yes, there's a full range.
There's a question around what information to enable us to provide a plug-and-play solution.
I think I can answer that one. The information that generally is needed to be able to provide that solution, the plug and pump solution, is generally, is it single phase or is it three phase? At the pipework side, installation on site. I think pumping stations that will be phased. I think a lot of the similar duty points, they're going to be operating on smaller pipework, up to 3 inch. Really, what type of installation is it? Is it guide rails in there presently? And then it's a case of just selecting the right pump. It's the voltage and what size pipework and is connection.
So this one, after a bit of a break, is another question. Bit of a break is around to what extent are these private pumping stations in rural rather than urban areas? I think you mean by rural, what we have seen is that in terms of one-off, such as farms, not many, and properties are not being picked. The private pump adopted are ones that are property, so single environments aren't picked up from this. In villages where new development put, and of course as well, it's a lot of these put in 3, 4, 5 new houses and needed to pump the water to the sewer, wastewater to get it to the sewer. Okay, there's a question here about if a water company is using GRM for large numbers of pumps, can the user integrate all their pumps into a single report to find those, for example, and if you it showed an image of a number of pumping stations in a particular area, and of activity going on. So if that's a development to take it to that level. What we can say is that GRM today pumping stations, so you can compare, you can see where the problematic sites are by level of interrogation as we move through the next version of GRM solutions that we're currently working live in parts of Europe at the moment on. a question around what is the expected life cycle of an auto adapt pump. Matt, maybe one for you. I think what I would say in the first place, from my perspective, a pump's life is only as good as its initial selection, and if you get the right pump to start with, because of the application and the duty that it needs, it should last in the same as any wastewater pump. Matt, do you want to expand on that?
Life of that pump, again, I think comes to a lot of down of the taken through its life cycle. But you know, I would be more than happy that if it's having its you know, main that's been taken to standard 5 years without you know, I think
Question
it's a
around
bit of a how long's a
the
piece
initial
of
cost
string.
comparisons
We
between
know
the
what the
standard
service intervals
starter
are. We know that it's a
pump system
3,000
and the
hour
auto adapt.
between
And again, I
services. So if you
think
put that into contrast on usage, you know, we'd be looking at
the answer
you
to
know,
that,
some
or
really good
to open
sort
that
of length of times before
response,
these
it does really
pumps are going to
depend
need
on
some
what a standard starter is.
any sort of major
Um,
service.
A standard
So
starter
yeah, no,
could
I
be
think
as simple as
it's
the
a bit of
image
a
we
tricky
showed
question,
earlier,
that,
a small
but yeah, well worth asking.
control panel with standard starters, or it could be more towards a Form 2 and a Form 4 panel type of construction that the water companies would typically use. And what we said there is it's all about flexibility, and that the auto adapt can link in with those. It can also, as we could see from the images and from the trial that we showed, is that it can be as simple as just the CIU unit with some sort of breaker to protect and keep the electrical integrity of the overall system. So it's a tricky one to answer that, but you know, you talk about a Form 4 panel costing you thousands of pounds, down to a standard starter costing you a couple of £100 perhaps, to a CIU unit costing you about £200 all integrated. But importantly, taking up a lot less space than any of the other starter configurations that we could have.
Pick up
Around
the question whether it's GRM
pump
based
controllers
or
optimize on the
GSM.
efficiency of the
It's
individual
actually, it is
pumps.
GSM and GPRS. It works over those two.
This is assuming that this is
systems.
about the auto
So yeah,
adapt
that can
changeover
work as a SCADA interface
logic.
system. Again, like I spoke
I
about.
think they change over. Matt, do you want to
on
answer
a
that? But I think it's to do with ours.
Yeah, the auto adapt will change the duty cycle of the pumps themselves. So it can
There's a question about
that
installed
efficiency by
some of
obviously
the
changing the cycle of those
solutions
two
that we've talked
pumps.
about today, and
So yeah, I
think
think it can do it
we've
on that
actually installed
sense.
auto adapt with most of the water.
But
However,
the auto adapt does not change the
we're
speed
currently
of the
trialing
pump
following and
or its
tracking
operating parameters. It is mainly,
closely
you know,
with
it's only
a
turning
number
it
of
on
sites
or off.
with Thames Water
it's not
Wastewater at the
regulating
moment,
it
so that we
in
can
that
start to
sense, but
see
in the role of sort of
how these are
making sure that
progressing
both
as
pumps
part
are
of
getting equal
moving
life,
forward towards 2016 and the adoption of the pumping.
get the best out of their life. It definitely does do that.
Question about where have we installed some of the solutions that we've talked about today. I think we've actually installed auto adapt with most of the water companies now. However, we're currently trialing and closely with a number of sites with Thames Water, Wessex Water, and South West Water, so that we can start to see how these are progressing as part of moving forward towards 2016.
With the reliable is the barometric pressure sensor. What I can say is this product has been actually in the
Okay, well,
marketplace for over.
I think that's pretty much all of the. What we will do
So we
is
know
we'll come back to individuals
the technology
with
that's
some
sat
more detail on some of these
within
questions,
the
and
auto
if you
adapt
do have any more,
feature.
I'm sure
Is
you can upload them onto the over the coming weeks, and we welcome the opportunity
market. It's used
come back to you on some of
extensively in Europe
those
as
questions in a little
and
bit
the
more
UK.
detail. I'd just
And
like to end
we've
by
not really had
thanking
any
you
problems
for
to speak of.
signing up for this and
It's a
coming
reliable
into
sensor.
the call
Again,
today. I
with
hope you found it
sometimes the
informative.
fat content that you
And
get within these
needless to
stations
say, please, if you've got any more questions,
can
please
cause a
do
lot of issues with float
ask
switches.
us, and
But
we
obviously it
will
doesn't cause
try
those
everything we
sort of
can
issues with
to
this
help
barometric
you
pressure switch.
with those.
So no, it is very reliable.
Thank you.
It to sort of take this further, obviously we do have further presentations which go into very finer detail of the barometric pressure switch and how that works and stuff. So yeah, we'd welcome any more sort of communications, and we can answer that probably in a little bit more in depth for you.